point on the graph or a low point on the graph. Today we're going to be talking about the absolute extrema, so we find the highest point on the graph and then the actual lowest point on the graph. And one thing that I think is weird, especially I remember kind of back when I first learned it, you would think that they have like kind of the exact same steps. You're like, well, we're still talking about a minimum, we're still talking about a maximum. But since we're talking about the highest or the lowest point, it ends up being a little bit differently because we will have to go back and find the y value that's associated with it. And there are different ways that I can teach absolute extrema, like the AP exam itself, our early College Board released like a whole, it was like a 30-page PDF of like different ways students can show work to justify the absolute extrema. I'm showing you the easiest way. So like, if you look it up online, you might see some other ways, but I'm showing you the shortest, easiest way that still gives you full credit, because that kind of is what matters. So with absolute extrema, let me get off of relative extrema. I did want to talk about first the importance of endpoints. So for absolute extrema, oftentimes when you're finding absolute extrema, you will be looking at it over an interval. So when we do relative extrema, the problems are usually worded, unless it's trig, that like just from negative infinity to positive infinity. For absolute extrema, it is going to give you endpoints, which is going to be kind of introducing kind of this theoretical thing, especially when you start having open circles or non-included endpoints. And what I mean by that, so like in this blue graph, we can see there is clearly like an absolute minimum. That is the lowest point on the graph. And the end point ends up being the absolute maximum. Some things that you notice about that, so like the absolute minimum does occur where we have like a horizontal tangent line, but endpoints are not necessarily critical points. We'll have to have some other way to deal with endpoints on these graphs. Where weird things start happening again is when you have open circles on an interval. So like in this green graph, it definitely has an absolute minimum. And what's weird, the highest point you see right here is an open circle. So this graph would be considered to have no absolute maximum. Which might sound weird because you're like, all right, well, if there's an open circle, that means there's a point that's like right below that open circle that could be the highest point. But in math, you have to kind of think about what that open circle means. When we draw that open circle in math, it means that you are going to continuously get closer and closer and closer to that open circle, but you'll never be able to reach it, because you can always find some decimal that's going to be slightly closer to that open circle. So when we have open circles on our intervals, we're going to exclude those values from being an absolute min or an absolute max. Also going off of that, so if I say there's no absolute max, like we're not going to include like the next highest point, we just say in general that graph has no absolute maximum, because of what open circles mean when you get down to like the theory of like math and like kind of what they represent. So then like two other graphs, like I just went ahead and used the same graphs and kind of switched it around. This red one has an open circle on the left-hand side, closed on the right-hand side. That first open one doesn't matter. We still have an absolute minimum. This one would have an absolute maximum. The purple one, similar to the green one above it, it has an absolute minimum. There is an actual lowest point on the graph. But the highest thing we see is an open circle, so this graph would have no absolute maximum. So how do we deal with those endpoints? One thing that's nice about absolute minimums and absolute maximums is we won't have to worry about making a sign chart, because we can just find the y values that go with certain t values. So I like to tell students, like, if you can make a t chart, which is basically like algebra 1 still, if you can do a t-chart, then you can find absolute extrema in a calculus class. So for the example that I want to look at, we did relative extrema yesterday, so I'm not going to kind of review them. We're just going to look at absolute extrema. So when you are finding absolute extrema, there's first step is going to start very similar when you're doing relative extrema. The first thing that you want to find is you want to find the critical points, which we know the critical points occur when the derivative is equal to 0 and where the derivative is undefined. And then instead of making a sign chart, since we want to find the highest value and the lowest value, we are going to create a candidates test. And I'll explain what that means in a second. Of critical points and the endpoints. So mainly what we're going to be looking at today is like what this thing called a candidates test in, and then the other thing we'll need to remember, since these are absolute extrema, we will still include the critical points, but since a highest point or a lowest point can also occur at an endpoint, we'll also include endpoints on that. And a candidates test is basically going to be a t-chart. Like you'll have x values and you're going to plug it into the original function. So I just have two examples we'll look at today, because again, this topic, most students, like once they see it, they're like, oh, this is pretty straightforward. The calculus part comes into, of course, finding the derivative and setting it equal to 0, and then the rest is just us going back and trying to find where where the highest y value is, and then where the lowest y value is. Anyone still writing that before I change the slide? Yes. All right, so here is my first example. So in this first example, I won't do this every time, but I am going to find both the absolute extrema and the relative extrema, just so you can kind of see the differences of what we did earlier in the week and then what we're learning today, just so you can kind of see how they compare, how they're different, but then also how they're the same. So if you're looking at this problem I have given, f of x is equal to x to the fourth minus 8x squared plus 3. And we are defining the interval from -1 to 4. So again, whenever we have absolute extrema, you're almost always going to have an interval. Things that you want to pay attention to when you're looking at that interval, like which one is included and which one is not included. So when I'm looking at this one, that -1 is going to be a closed circle, but then that 4 is going to end up being an open circle. So whether you're finding a relative extrema or an absolute extrema, the first step is you need to find your critical points, basically where you have horizontal tangent lines or where your derivative is undefined. This is a polynomial, so the derivative is never undefined, so I just need to find when it's equal to 0. So I can go ahead and find my derivative. And this one's pretty straightforward with the power rule. So I have 4x cubed minus 16x, 3 goes away. And then when I set that equal to 0, factor and find my critical point. So I have 0 is equal to, I'm going to factor out of 4x, and that's x squared minus 4. I want to be fancy and factor that just a little bit further. X squared minus 4 is going to be x plus 1 times, or excuse me, x plus 2 times x minus 2. And so where are my critical points? We have critical points at 0, 2, and -2. One thing we can do with this problem, it does tell me my interval is from -1 to 4. So what can I do with one of those critical points? Get rid of it. Like -2, like thanks for knowing you, but you're not in the interval, so I'm not going to worry about it. So here's where the different types of extrema branch out. So relative extrema, these are going to be the ones where you would have to create a sign chart. That's what we were doing on Monday, and then really didn't look at it yesterday, but that's what we did on Monday. So I'm going to do that quickly since that's just kind of like the review. So remember when I'm doing relative extrema, we make a sign chart with the first derivative. We have our key factors going down the vertical. And again, I tossed out that -2, so my only critical points are 0 and 2. And then I can figure out where those are positive and where those are negative. Well, 4x is going to be negative when you are less than 0, positive when you're greater than 0. X minus 2 is negative when you're less than -2, and then when you are greater than 2. x plus 2 on the interval that we're looking at, it is always going to be positive. Yes?
Why do you need to write x plus 2 if it's critical point with it?
So you still want to include, the question for your home is why would it include x plus 2? You want to include it because if it happened to like always be negative, then it would affect the sign of the draw. And that's one thing you want to be careful with. When you're doing the sign chart, it's the sign of y prime, like for the whole first derivative. So we can see that this first derivative is 2 negatives, so it's going to be a positive, a negative, and then a positive. Good review from Monday. Looking at 0, do we know 0 is going to be a relative minimum or a relative maximum? Maximum. So I know that x equals 0. I'm just going to write a short answer, is a relative maximum. How do we know it's a relative maximum? Because the derivative changes from positive to negative. My board is possessed positive to negative. And then we can look at x equals 2. What do we know x equals 2 is going to be? A minimum. And we know it's a minimum looking at that sign chart because it goes from negative to positive. So we know the derivative of that function is going down and then back up. Y prime changes. I'm going to squeeze it down here. From negative to positive. And that's really messy, but it's there. So that's what we looked at on Monday. Again, I think at this point, most of you are very comfortable with the sign chart, but that's going to be a relative extrema. Where we are going to have to do things differently, so here's the new stuff for today, is when we see absolute extrema. And the reason why we need to do something differently is like when I look at that sign chart and I say x equals 0 is a relative max, I just know that there is a high point on the graph at x is equal to 0. I don't know if that's the highest point, like do the endpoints end up going higher than that value, or do the endpoints stay below that value? So when we are doing absolute extrema, instead of doing the sign chart, you are going to create what's called a candidates test. And where that word is coming from, these are basically the potential candidates for an absolute extrema. And what you're going to put on a candidates test is it's just a fancy t-chart. So don't think of it anything more than that. So we have like our x values and then our y values. And it is important to point out that those are y values. So they're coming from the original function. We know that a max will be like the highest y, a minimum will be the lowest y. And on my t-chart, we have to include endpoints and then we have to include critical points. And I like putting them in order. So my endpoints are -1 and 4. The critical points we had between that interval was 0 and 2. And we just want to plug those x values into the original function. One last thing I like adding to remind myself, because we know open circles can do weird things in these problems, is I'll put like a parentheses or a bracket to show that something is included or not included. So looking at the interval, -1 had like the less than or equal to on it. So I know that this would be a solid circle endpoint, so it's included. The x was less than 4, there was no equals to there. So I know that that's going to be an open circle endpoint, so I'm going to put a parentheses around that 4. And that is important because remember that if like a highest value ends up at a parentheses, then there's going to be no absolute max. Or if the lowest value ends up on a parentheses, there's going to be no absolute minimum. And then now from here, I'm going to use my calculator. We're just going to plug these into the original function. Again, common mistake, make sure you plug it into the original function and not the derivative. We just want to find the actual points on the graph. So go ahead and do that. I'm going to cheat on my calculator, and we just want to evaluate what those would be.
Mr. Brown,
Yes.
can you explain one more time why you didn't include the other factor, like for both of them, I guess?
Why I didn't include -2?
Yeah.
I didn't include -2 because it was outside the interval that was being asked about.
Okay, thank you.
If I didn't have that interval there, then obviously I would then use the -2 there. all honesty, doing the absolute extrema tends to be more tedious than anything. You just have to go back. Instead of having to figure out whether things are positive or negative, you actually have to go back and figure out the number, which to me is a little bit more annoying. So again, we made our candidates test. One thing I recommend doing, it's not required, but again, you have to kind of think about more along for the AP exam, you have some stranger grading your work. I recommend also will make your justification easier if you label your T-chart a candidates test. Like it sounds weird to do that, but different teachers teach it and call it different things. So on the AP exam, I would recommend like calling it candidates test. So we plugged it in, we had our endpoints, and then we had the critical points. So if I'm looking for my absolute extreme, let's do the absolute minimum first. Well, what's the lowest Y value we see? Negative 13. So there's my lowest one. So here's my justification. I can say something like x equals 2 gives an absolute extremum, absolute minimum to be clear. Or if I just want to find what is the absolute extreme, I can say like negative 13 is the absolute minimum. Like both those statements are kind of equivalent. You'll like how we justify these. So like when we do relative extreme, you can say something like, the first derivative changes from positive to negative. To justify absolute extreme, you just have to say C candidates test. So as long as you showed your work clearly, just tell the AP grader to go look at your work. So there's the absolute minimum. And then here's where people start messing up at. Looking at your candidates test, where do we see the highest Y value at? At 4. So we see the highest Y value is at 131. But what do I know about that 131? It's not included. So that 131 is on an open circle. So it doesn't mean you're going to go to like the next highest one. That just means you have no absolute max. So the highest value we see is not included. So this has no absolute maximum. The justification would be the same C candidate says. So again, that's what I like to say when you're doing absolute extrema. If you can make a T-chart, and as long as you remember to exclude endpoints that are not included, then do that. Of course, I could change this problem. If I had put in less than or equals to by that 4, then that endpoint would be included, and then you definitely would have an absolute maximum. Questions on that problem? All right, go ahead and try, well, there's a graph of your, here's what the graph looks like. So we can see there was an absolute minimum and then no absolute maximum. But go ahead and try, we love trig, so go ahead and try that one. Slash, y'all hate trig, so there's some practice. So again, I am looking for the absolute extrema. So again, you just need to find critical points and then basically make a T-chart with the endpoints and the critical points on it. Make sure when you find that T-chart that you plug those X values into the original problem and not into the derivative. And this is actually where we're stopping at today, so there's not much else I can do with this type of problem.
Should we factor out?
You wouldn't have to. Since you're not making a sign chart, you don't have to worry about factoring as much. So there's my work. Again, I know I probably worked a little bit faster than you, because I've been doing this a while. But I do think these are easier than having to do like a sign chart. Like you don't have to worry about factoring, like you just need to find when a derivative is equal to 0, possibly when it's undefined, and then just make a t-chart. Things where I often see mistakes on, people forget to include the endpoints on it. Sometimes some weird things can happen, like maybe you find like 2 critical points, but they're not within the interval at all. So maybe your candidates test just have the endpoints on it, which can be kind of weird. But this one, we take the derivative, set it equal to 0. We have 1 critical point from 0 to 2 pi. So my candidates test, I have the endpoints and pi. 0 is included, 2 pi is not included. Maybe that's important to pay attention to. And then we just want to plug it into the original function. In green, we see those are the y values. The lowest value I see is 0, and the highest value I see is 6 pi. Using that though to answer the question, looking at the lowest one is 0. Is that 0 included on the graph? Yes. So we know that the absolute minimum, and it says to find the absolute min-max value. So the absolute minimum is 0. The highest value we see is 6 pi. Is that 6 pi included? No. So then we have no absolute maximum. And then my justification, C candidates test. And we can leave our answer like that. Again, I can easily change this problem. Like I often do this when I'm making like different versions of a test. Like I can change the interval and maybe say like, if my interval was 0 is not included, but then 2 pi was included, I can completely change what the answer would be. Like if I changed it and said 0 was not included, it would have no absolute minimum, but it would have an absolute maximum. I could change it and they both have brackets on it, and it would have both an absolute minimum and an absolute maximum. So that's where those endpoints are important. And especially thinking about, are they included endpoints? Are they technically open circle endpoints? Any questions on absolute extrema? All right, so that's where I'm going to stop at today. There's the fun graph if you want to see it, but we can't see there's clearly an absolute minimum. It was at the endpoint, and then no absolute maximum for that one. Your homework is in the textbook again. If I can see where I shared the updated calendar. There it is. So what you have to work on, so after your quiz, we have homeworks 4 and homeworks 5. Homeworks 4 was again doing the relative extrema, so what's new today is this homework 5. I want you to do, it's actually not that many once you start counting it out, but 20 through 40 multiples of 4. Please skip 32, you do not need to know how to do the type of function that is in number 32. And then 55 and 56. 55 and 56 do have like multiple parts, but it's just kind of like I changed, the intervals changed each time of like whether you're including or not including the endpoints. Tomorrow will be like a review day that I will kind of use just to kind of pull all this together and make sure we can distinguish the differences between relative extrema and absolute extrema. And then as one of your 12 summative assessments, you're going to have a take-home quiz, just because I don't feel like taking up class time for it, but that quiz will be available to you at the start of the period on Friday, and it will be due on Tuesday, which I have as November 10th, but I feel like Tuesday might be November 11th. No, it's the 10th. So yeah, that is, we'll leave it at Tuesday on the 10th. So yeah, so y'all can go ahead and get started on that. Definitely ask me questions as you're working. Again, making sure you kind of distinguish between like whether you're working in homework 4 with the relative extrema or homework 5 with the absolute extrema. Also at this point, hopefully I've had a chance to look at your quizzes. Definitely don't hesitate to ask me questions on the quiz if you have those as well. Moving forward next week, we have just 2 more topics to learn. We have position, velocity, acceleration, and then we have something called implicit differentiation. And then like we're practically almost at Thanksgiving break. So your test is going to be that Wednesday before Thanksgiving break. But y'all can go and get started on that homework and ask me questions as they come up. And Dennis, I was just going to remind you that I have your recovery test set up to start right when school ends.
Okay.
If you want